So in the series of videos, we are talking about various standard functions. In the sixth part, building from the previous one, we are going to talk to you about fractional part functions. So what is the definition? G from R to R, gx is the fractional part of x, which is x minus box x. In the previous one, we have talked about box x or the greatest integer function. So building on that concept, this is what we learn. So if you remember what we talked about, suppose there's a person standing here. He starts walking to the left, and the first integer he reaches is the basic, greatest integer function that it actually represents. Now forget about all these things and just concentrate on the distance that the person has to cover. This distance is known as the fractional part. All right. Now let's see some example. 2.1. So this is the input. This is the greatest integer. And if you take the value and the difference, this is what you're going to get. Similarly, 4.7. This is the greatest integer. The difference is 0.7. Now, it might look like we're just dropping this particular portion, the particular, greatest integer or the integer initially, and we are getting the answer. But again, just like the previous one, be very careful about negative numbers. If you simply write this as 0.9, this is going to be absolutely wrong, because here this is minus 4, the box is minus 4, and if you consider the difference, the correct answer would be 0.1. If you take any integer as an input, the output will be the integer itself, so the value will be actually 0. Look at all the values as one important thing that you are going to notice. The values will lie between 0 and 1, 0 included, 1 excluded. Now you can clearly understand that the steps, the number of steps or the kind of distance it covers cannot be more than 1. And also we are talking about distance, so it cannot be negative. So if you think from this particular significance, you will understand this better. So domain and range is pretty clear. Now let's look at one thing. This is very crucial. If you just have the input 0.3, the output will be 0.3. Talk about 1.3. So this will be 1.3 minus 1, which is again 0.3. So building on that, you will actually see that it will keep on repeating after the value 1. So this is periodic with 1. Now that we understand that the domain is there, the range is there, we actually see that this is the periodicity that we need to explore here. So whenever you consider the graph of any function that shows this periodicity, the graph will keep on repeating. So if you just concentrate one part and get it correct, you can repeat that and then actually get the rest of the graph. What we are going to do is we are going to concentrate on the part 0 to 1. You will actually notice that whatever be the input, the box will be 0. So the output will be same. So in this position, this graph is nothing but the identity function. So this is how it will look like, because we already know about identity function and how their graphs look. So repeating on the basic thing that it's periodic with 1, so the rest of the things will actually look like this. So this is the graph of the fractional part function, and also it is periodic. So whenever you have any property regarding periodicity, it's going to be very important. So learn about it. In the next part, I'm going to talk to you about 2 more special functions. So stay tuned.